2026 A-Level Combined Mathematics Paper 1 Part B question number 11 Part B. Part A of this same question was discussed in a previous video, link in the top right. Part B of this question has to do with the factor theorem and the remainder theorem. The question says, let the function of x be given by x to the power of 4 plus ax cubed plus px squared plus q, and let the function g of x be given by x to the power of 4 plus bx cubed minus qx squared plus 2x minus p, where the values a, b, p and q are all elements of the real numbers. It also says it is given that x plus 1 is a factor of f of x and that the remainder when g of x is divided by x minus 1 is equal to 4. Now with this, we are asked to show that a is equal to b. After that, the question then says it is also given that the equation f of x equals f of negative x has a non-zero solution. So at least one non-zero solution. Now with this, we are to show that the value of a is equal to 0 and that p plus q is equal to negative 1. Finally, the question says, hence, show that x plus 1 is a factor of the function g of x. Now to start off with this question, we need to consider this statement and apply the factor theorem and remainder theorem in order to get some equations that we can then use in order to find out what a, b, p and q are equal to. So starting off, if x plus 1 is a factor of f of x, we can say if x plus 1 is a factor of the function f of x, then by the factor theorem, since when x is equal to negative 1, the factor is equal to 0, if we apply x equals negative 1 into f of x, we should get f of negative 1 being equal to 0. This is what the factor theorem tells us. Now with this, we can apply it into this equation and get some interesting results. But before that, I am next going to consider what the remainder theorem has to say about this statement. Now according to remainder theorem, if g of x has remainder 4 when divided by the factor of x minus 1, then since this whole thing becomes 0 when x is equal to 1, we can say by the factor theorem, or rather by the remainder theorem, that g of 1 must be equal to the remainder, which is 4. So g of 1 is equal to 4. This is our first equation, which I'm going to call equation number A, and this is our second equation, which I'm going to call equation number B. So A comes from the factor theorem and B comes from the remainder theorem. Now what we can do is to apply the actual value of negative 1 into f of x from A and see what we get. And similarly, we're going to apply x equals 1 into g and see what we get. So for A, if we apply f of negative 1, we are going to get negative 1 to the power of 4 plus a times negative 1 cubed plus p times negative 1 squared plus q. So applying that on the left hand side of our equation, we get negative 1 to the power of 4 plus a times negative 1 cubed plus p times negative 1 squared plus q. And on the other side, we have equals 0. So that's what we get when we apply equation number A with x equals negative 1 into f of x. We get that equation with negative 1 substituted for x. Now if we simplify this, we can see negative 1 to the power of 4 is equal to positive 1. Negative 1 to the power of 3, however, is equal to negative 1, and therefore that times a is going to be equal to negative a. And then the next term is p times 1, which is plus p, and the last term is plus q. So we get 1 minus a plus p plus q equals 0. And I'm going to call this equation number 1. Now after this, if we do a similar thing for equation B, and we do b gives us and try to substitute x equals 1 into the equation g of x, we can see we get x to the power of 4 rather, plus bx cubed minus qx squared plus 2x minus p. And therefore we get 1 to the power of 4 plus b times 1 cubed minus q times 1 squared plus 2 times 1 minus p equals 4. Now simplifying this one down, we can see on the left hand side we get 1 plus b minus q plus 2 minus p equals 4. And from this we can see, if we subtract 1 and plus 2 from this side, we can get b minus q minus p equals 1. And this is going to be equation number 2. Now with equation number 1 and equation number 2, what we can do is to add them together. And if we add them together, we can see this p will cancel this negative p and this q will cancel this negative q. And that's exactly what we're supposed to do. So doing 1 plus 2, we can see we are going to get this and this cancel for this and this, leaving us with on the left hand side a 1, a minus a and a b, and on the right hand side a 0 and a 1. So adding them together, we can see on the left hand side we have 1 minus a plus b equals, and on the other side we have 0 plus 1. So just 1. Now simplifying this, we can see if we remove this 1, we get minus a plus b equals 0, and thus if we rearrange, we get a equals b. And with that, we have solved the very first part of the question. We have found that a is equal to b. Now after this, if we consider the next part of the question, the next part of the question says it is also given that the equation f of x equals f of negative x has a non-zero solution. So at least one non-zero solution. And with that, we are asked to show that a is equal to 0 and also that p plus q is equal to negative 1. Now for this, what we will do first is to try substituting in this equation on the left hand side and right hand side with the actual function f of x. Now considering that on the left hand side, we just have the function f of x. So therefore going down, we can say if f of x equals f of negative x, on the left hand side, we are just going to have x to the power of 4 plus ax cubed plus px squared plus q. Now on the other side, instead of x, we have negative x, and therefore substituting, we can see we get minus x to the power of 4 plus a times minus x cubed and then plus p times minus x squared plus q. Now simplifying this down, we can see on the left hand side we have a q and on the right hand side we have a q, and we can subtract both of them off. Other than that, we can also see on the left hand side we have x to the power of 4, and when you do minus x to the power of 4, we are also going to get x to the power of 4. Now similarly, if we consider the next few terms, we have ax cubed here, but over here we have minus ax cubed. But for the next term, we have plus px squared, and from this side we have minus x squared, which is also equal to x squared, and therefore this term becomes plus px squared. Now the term after that is plus q, and this term is plus q, and we can see x to the power of 4 is equal to x power of 4, and then px squared is equal to px squared, and q is equal to q, leaving us with just the last few terms remaining of ax cubed being equal to minus ax cubed. Now rearranging, we can see we have 2ax cubed being equal to 0. Now if this is the case, we can see we have a times x cubed being equal to 0 after dividing by 2. Now the two ways that this can be true is if either a is equal to 0 or x is equal to 0. There are no other ways for this equation to hold true. Now in the question, they said at the very top here, they said this equation has a non-zero solution. Now according to that, the value of x for this solution here cannot be equal to 0. So this is false. So we can say since the above equation is said to have a non-zero solution, we can conclude that x is not equal to 0. Now if x is not equal to 0, the only other viable solution is a equals 0, and we can say therefore a must be equal to 0, and with that we have found that a is equal to 0. Now with this result, in order to prove the second result in the question, which is that p plus q is equal to negative 1, all we have to do is to go back to equations 1 and 2, pick one of them and substitute in the value of a. So if we do equation number 1, we can see we get 1 minus a, which is 0, so minus 0, plus p plus q equals 0, and you can see that will directly give us p plus q equals negative 1. Now another thing I'm going to do here is to also use the result that a is equal to b to say here that b equals 0. Now after saying that, I'm going to go down and do what I just did up there by taking equation number 1 and substituting in the value of a, which is equal to 0. So doing so, we can see we get 1 minus a, which is 0, plus p plus q equals 0, and hence if we remove this and take this 1 to the other side as minus 1, we get p plus q equals negative 1. And with that, we are done with the second part of the question and can now move on to the last part of the question. So the last part of the question says, hence, show that x plus 1 is a factor of the function g of x. Now there are two ways to do this. One way is to try to factorize the function g of x. Another way to do it is to simply use the factor theorem, substituting the value that's going to be required for this thing to be equal to 0, which in this case, in order to make x plus 1 equal to 0, we need x equals negative 1, and we can substitute g of negative 1, and we know, according to this factor theorem, g of negative 1 must be equal to 0. So going down, all we need to do is to show that g of negative 1 is equal to 0. So we can write something like, if x plus 1 is a factor of g of x, then according to the factor theorem, g of negative 1 must be equal to 0. Now we can test this by substituting negative 1 into g and seeing what we get. So going up, g is x to the power of 4 plus bx cubed minus qx squared plus 2x minus b. So going down, if we substitute, we're going to get g of negative 1 equals negative 1 to the power of 4 plus b times negative 1 cubed minus q times negative 1 squared, and then plus 2 times negative 1, and finally minus b. And if we simplify this, we can see we get 1 here, we get b times negative 1 here, which is going to be negative b, which is equal to 0, since b is equal to 0, so this part's equal to 0, and then we get minus q times 1, which is minus q, and here we get plus 2 times negative 1, which is minus 2, and minus p. Now considering what we have here, we have 1 minus 2 minus q minus p, and this can be taken to one term as minus 1 minus p plus q, and p plus q is known to be equal to minus 1 from up here. So if we substitute that in as well, we can see we have minus 1 minus negative 1, which is equal to 0, and hence g of negative 1 is equal to 0. Now we can say, since g of negative 1 is equal to 0, x plus 1 must be a factor of the function g of x. So we can say, since g of negative 1 equals 0, x plus 1 is a factor of the function g of x. And with that, we are done with this question. Now finally, let's go up and discuss the marks order for this question. So at the start of the question, when you apply the factor theorem to say that f of negative 1 must be equal to 0, you get 5 marks, and similarly, when you apply the remainder theorem to say that g of 1 must be equal to 4, you get another 5 marks. Now after that, when you apply each of these equations to f of x and g of x, and from f of x's equation, you get 1 minus a plus p plus q equals 0. For this equation, you get 5 marks. Similarly, when you apply it to g of x and get this equation, b minus q minus p equals 1, you get another 5 marks. Now then after that, when you combine the two equations to get that a is equal to b, you get another 5 marks after that. Now moving on to the next part of the question, when you apply f of x equals f of negative x and actually substitute the values of the functions, for substituting f of negative x correctly and simplifying the negative signs correctly like so, you get a total of 10 marks. Now after that, when you cancel out all of the same terms and get left with 2ax cubed equals 0, and thus ax cubed equals 0, and thus a equals 0, x equals 0, for this you get 5 marks. After this, when you say that since this equation has a non-zero solution, x cannot be equal to 0, and thus this is invalid, meaning that the only solution here is a equals 0, and writing a equals 0, you get 5 marks for that. Now after that, when you then use the result of a equals 0 in either equation 1 or equation 2 and substitute and get the answer of p plus q equals -1, you get another 5 marks. After this, when you then apply the fact that if x plus 1 is a factor of g of x, then by the factor theorem g of -1 is equal to 0, and when you try g of -1, substitute, simplify, and get that it is in fact equal to 0, getting it equal to 0 gets you a final 5 marks. Now this 5 marks would either go to that, or it could go to actually stating that since g of -1 is equal to 0, x plus 1 is a factor of g of x. I'm not too sure on where it goes, but I'm going to put it here for now. Now with that, we are done with this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching, and goodbye.